let's get started. And today I'm going to talk about the combination of the incubating Apache project called Apache Hivemall and Apache Spark or PySpark. That's the combination. And this is Takuya, and I'm a data science and machine learning engineer at ARM, and also I'm an Apache Hivemall PMC. All right. So main topic I'm going to speak in this session is about machine learning in query language. It sounds like weird, but it is. So think about the scenario like that. So you have to solve a machine learning problem on massive data set stored in somewhere like data warehouse. How to overcome the problem, how you can provide a solution. In reality, we have to understand a lot of things in order to achieve the goal. For example, in order to understand machine learning techniques, we do need to run machine learning theory, or we have to understand the math or stuff like that. And also, in order to work on the massive amount of data, we have to make sure the scalability in some sense. At the same time, so when you think about data warehouse, what kind of open source software or some enterprise software we can use, and where the data is stored. So many questions are coming as a result of this kind of consideration. And what Apache Hivemall does is to provide a solution to that kind of situation. So basically, you can create a machine learning query or machine learning code by writing 10 lines of queries in the scalable manner. So once you write this kind of query, what Hive does is to train the machine learning model in the scalable manner inside of the Hive or Spark or somewhere like that. So that's the solution what Apache Hivemall provides you. So Apache Hivemall is an open source query-based machine learning library, and it's incubating from the 2016. And also, we have 6 PMC and 3 committers, and we are actively working toward graduation from the incubating projects. So we do need to improve documentation, and also we have to provide one more Apache release, or we have to do a lot of things, but it's an ongoing project. So today, I'm going to talk about, first of all, the brief introduction of Apache Hivemall. And also after that, I'm going to move on to the main part of the talk. So how Hivemall works with PySpark or simply Spark. And why the combination of Hivemall and PySpark is preferable in the practical situations. So first of all, let me start from the basics of Hivemall. As many of you may already know, Apache Hive is the open source data warehouse solution. And you can store the massive amount of query in the scalable manner, and you can access to the data by writing a query. It's just like standard SQL. So you can apply create table, or select, join, group by, or order by, and also it's scalable, so you can apply the cluster by operation on top of that. So, as the name suggests, Hivemall is an extension of the Hive capability. It's basically a collection of user-defined functions of Apache Hive. So there are 3 different types of user-defined functions in Apache Hive, and one is the just simple user-defined function, which gives you the one-to-one mapping from the original table to the new table. So in case of machine learning, for example, the normalization corresponds to this kind of operation. And another user-defined function is called UDAF, user-defined aggregation function, which actually aggregates multiple rows into single row. So for example, in case of machine learning, evaluation could be part of that. So you have to aggregate all combination of the expected output and the prediction result, and eventually you can get the accuracy of prediction. Or another user-defined function is called UDTF, user-defined tabular function, which gives you the brand new table as a result of a specific operation. So in the context of machine learning, the training corresponds to that. So you can feed your original record to the function, and eventually you can obtain a brand new table as a machine learning model. So basically, Hivemall internally implements those kind of user-defined functions, and it's just aggregates and packages for your use. And I would say there are 4 different characteristics basically in Hivemall. And it's easy to use, and it's scalable, and it's versatile, and also it runs in multi-platform. And in terms of the, first of all, maybe let me show you some examples in the real world. And actually, this is coming from my company, and my company is ARM, a chip company. And our company is actively investing on some IoT industry. On that point, the data is really important, and machine learning is a crucial portion of that. For that purpose, our internal data management platform bundles Apache Hivemall. And also, the customer's data is stored in the scalable manner in our customized database management system. And customers can access the data by using either Hive or Presto. Both are the query engines. And for the Hive part, we internally bundles Apache Hivemall. So our customers can apply machine learning techniques to the data stored in their, their platform or our platform. Or another application is coming from the field of recommender systems. So for those who have attended the previous talk in this room, he talked about some recommender system techniques. And also Hivemall can be used for recommendation. And I actually wrote some research paper on it, and we demonstrated how it works in the context of recommender systems. So you can check it out if you are interested in. Or the good thing of Hivemall is actually you can do machine learning by using just SQL. So the only thing you have to know is about SQL basics. On that point, it is very easy to tell the basic of machine learning techniques. So it's actually used part of the e-learning, which is available on Udemy. So the audiences have to know only about SQL, so they don't necessarily have to understand mathematical details or machine learning theory or stuff like that. You can forget about it and how machine learning works and how intuitively it runs. That's the important part as a first step if you want to run machine learning. So e-learning, Hivemall is used. And in terms of the easy to use and scalability, like I showed, so for example, if you need to create a scalable logistic regression model, for example, if you use Apache Mahout, I don't know if you are using that, but if you use Apache Mahout, you have to write hundreds of lines of code to make it possible. But in case of Hivemall, internally, everything is already bundled. So the only thing you have to call is actually the regress or train logistic regression function as a part of the entire your SQL. And it just completed by 10 lines of SQL syntax or statement. And of course, it runs in parallel. And at the same time, when you think about machine learning, it's not only about purely machine learning. You have to work on the data itself, and you need to pre-process the data, or maybe you need to evaluate the accuracy of prediction, and eventually maybe you need to export the result to somewhere else or stuff like that. For that purpose, Hivemall also provides multiple utility functions to the users, like feature engineering or evaluation metrics, or there are a bunch of useful array or vector or map operations are available. And also, recently we have incorporated some sort of JSON conversion operations, which is kind of useful for pre-processing or exporting the table to the outside of Hive. And one of the most frequently used utility function is called each top k, the bottom of the slide. So think about the scenario like you have this kind of table. So item and user and score in the context of recommendation. And if you want to pick for example, top 3 items for every single user, what kind of query you have to write? It is possible, as I showed above of the slide. It is possible, but it's kind of complicated. And also, it's not that scale internally. So when you issue the query, it actually takes more than a day. Of course, it depends on the volume of data. But on our experimental environment, it took more than a day. But when you use Hivemall UDF, each top K, it actually finishes in a couple of hours because it internally bundles the bounded priority queue, and it makes the entire computation much more efficient. So that kind of utility functions are basically available as a part of the Hivemall package. And like I said, it is the part of the application called recommender systems. And we have many recommendation functions inside of the Hivemall. So actually, in the field of recommender systems, there are multiple options in order to achieve the goal, let's say the recommendation. So how to make recommendation, there are many options, and we do support multiple options in it. And not only recommender systems, but also we provide some natural language processing functions or geospatial functions. So for example, you can tokenize the natural language text into every single word. And as a result, what you can do is, for example, you can apply the topic modeling technique, which is also known as clustering in the context of machine learning. Or if the data is more like time series data, we experimentally implemented some sort of the anomaly detection or change point detection technique. So you can apply the data stored in Hive by writing simple SQL, and the result is kind of like much more sophisticated one. And in terms of the efficiency or scalability, we also provide some sort of a sketching technique, so-called, which gives you some sort of approximated result to accelerate the entire computation. So for example, in the context of a SQL, when you issue the query like select count distinct, it might take a longer time than you expected. But there is an approximated function called approx count distinct. It actually internally takes a little bit different approach to approximately calculate the number of distinct items from the target column. And eventually, your query runs much more faster. And also, we internally bundle Bloom filtering technique, for example. So there are many options to do the before machine learning or after machine learning step. And finally, Hivemall runs in the multi-platform fashion. So, the good thing here is Hivemall stands on the entire Apache ecosystem. So it runs on Hadoop environment. So what you can do is to run Hivemall functions on top of Spark, for example. So this is the Hive query, like I showed before. And it can be converted into, I don't think anybody is already using Apache Pig, but if you are interested in Apache Pig, it could be written like that. Or this is the main part of this topic, this talk. The query or Hivemall functions can be called from Spark environment if you use Hive context. So it's purely Spark code, but let's move on to the discussion to the PySpark part. So like I said, Hivemall function can also run on top of Spark. So it means Hivemall function can also run on top of PySpark as well. And installation should be very straightforward. So we provide a jar file to the users. So the only thing you have to do is to download the Spark jar file. So Hivemall Spark 2 point something. Currently, the latest version is 2.3 and 2.3. And the 0.5.2 is the Hivemall version. And incubating with dependencies, as the name suggests, it already bundles everything. So once you download the jar file, you can pass the jar file to the PySpark's SparkSession configuration, like that. So here's the SparkSession definition, and we're going to create a SparkSession. It experimentally runs on the local environment, and the cores is taken as much as possible. And for the configuration, we can, as the configure called spark.jars, we're going to pass the Hivemall jar file here. And the important part of this entire configuration is here. We have to put enable Hive support. And eventually, you can run any Hive UDFs from your PySpark code. So you can jump between the Python environment and Spark scalable environment. And like I said, Hivemall is basically the collection of user-defined functions. So you need to load the user-defined function to your Spark or PySpark environment somehow. And to do that, it just, the only thing you have to do is to issue the single query, spark.sql, and create temporary function. And for example, we have a function called Hivemall version, which just returns the latest version of the current version of Hivemall. So let's try to load the function from the path of the function, UDF. And eventually, you have access to the user-defined function. So from your SparkSession, spark.sql, and the SQL statement comes here. Select Hivemall version, and you want to see the result. And you can get the result. And it says the Hivemall version is 0.5.2 incubating. And the list of available functions are in the Hivemall repository. So if you are interested in the detail, you can see it. All right, so let's take a look at the more practical example of the end-to-end machine learning workflow from data preprocessing to evaluation by using the SparkSession that we created before. So in this example, I'm going to take the binary classification example for the customer churn prediction. So this is the public data, and I'm going to give the link if you're interested. But the data basically looks like that, the bottom of the slide. So every single row has the phone number. And a single phone number has a bunch of different attributes, like so where is the phone number coming from, and where is the area code, and depending on the usage, there are multiple attributes in it, like daily phone call minutes, or daily calls, or account length, or if this customer has the international plan or not, or stuff like that. And the final column indicates if this phone number has already been churned from your service or not. So this is the data we're going to use. And once you get the data, you can load the data in the form of data frame. It's actually a good thing if you're that's why we are using Python or PySpark here, right? If you are strongly focusing on only Hive, maybe you need to first of all, create table and load from CSV, and the schema is kind of like that. It's kind of frustrating. But if you have Python connector to your Spark, you can simply load the data in the form of data frame, and it's visually easy to understand, and it's easy to load the data to your Spark environment or Hive environment. So this is the churn.txt. The data is stored in the form of CSV file, so you can simply load the data here. And if you want to do that, you can apply some pre-processing to the data frame easily. Like you can modify the column name before creating a data frame, for example. It is also flexible. And if you only use Hive, it's not that easy, for sure. So let's start from pre-processing. So basically, the Python code looks like that. First of all, in order to give the query itself access to the data frame, you have to first create a view on the table or on the data frame. So as the name df, we now load the churn data to the data frame. So now we have to first call the create or prepress temporal view for the churn data frame, and the name is churn. As a result, you can get the access to the churn data from this entire SQL statement, which is coming from Hivemall functionality. So spark.sql, and inside of the 3 double quotes is actually the SQL statement, which is issued to Hive environment. And this entire query does the pre-processing. And eventually, you can get the pre-processed data in the form of a data frame, df preprocessed. And what it does is, I'm going to explain a little bit about it. So basically, the pre-processing, also known as feature engineering, can be done in the context of Hivemall like that. So basically, feature vector is represented as an array of strings. And every single string corresponds to a single feature in the context of machine learning. And in the field of machine learning, there are two different types of features. One is called quantitative features, which corresponds to some numerical representation of the attributes, like maybe the number of calls, or in case of the churn data, number of calls, or the minutes of the day call, or something like that. That can be numerically represented. And another feature is called categorical feature, which represents more like the categorical information, like if this customer has international plan or not, it's Boolean indicator, or which state this customer is coming from. This is also, one of the multiple options. That's the categorical feature. So for two of these features, a Hivemall provides a special function named the quantitative features and the categorical features. So you simply need to pass the name of a feature and the corresponding column name or value itself to the second and third arguments. And eventually, you can get the array of string, which actually means the feature vector. So for the quantitative feature, you can get this kind of array. Price is 600 and size is 2.5, and this is the representation of your data. Or in case of a categorical one, the gender is male, and the product category would be book or something like that. So those kind of preprocessing can be easily done by using the simple functions, quantitative features or categorical features. So let me go back to the previous query issued in the SparkSession. So inside of the query, we have categorical features function and quantitative features function. And eventually, we want to concatenate two of those quantitative and categorical feature vector into single feature vector so that we can directly pass the entire feature vector to the following training query. So what you can obtain as a result of this query looks like that. So international plan is no, and state coming from KS, area code is 415, and the female plan is yes, and night charge is 11.01, or stuff like that. So, basic attributes representing this specific customer is converted into array of string, which is feature vector. So this is basically the preprocessing for the data. And once you preprocess the data can easily be split into training set and test set if you want. So fortunately, the PySpark provides an interface called the random split. So you can randomly split every single record in the single data frame into, for example, 80% training set and 20% test set. So which gives you the easier implementation for your evaluation workflow. So now we have DF train table and DF test table. So what we do from now is to first create a prediction model, customer churn prediction model, by using the training set. And eventually, we want to evaluate the accuracy of prediction by using the hold audit, the 20% DF test records. So it's time to train the model. Similarly to the before, we're going to first create a view for the training table. So for the DF train data frame, we have to create a view named train in order to issue a query. And here, we also applied a query, spark.sql, and this time SQL looks like that. And the key part, or actually the Hivemall function itself, corresponds to the line is in blue, the train classifier. This function trains a classification model depending on the data passed to the function. And internally, the train classifier runs in parallel in the Spark environment. And obviously, the training is happening in the distributed manner. So eventually, maybe multiple outputs comes from multiple workers. So finally, you have to aggregate the prediction result, the training result into single model. So that's why we have feature and average and grouping by operation outside of the training function or statement. So let me give a little bit more explanation on it. So like I said, the train classifier actually trains a classification model for the data passed to the first and the second argument. And the first argument corresponds to the feature vector that we created before. And the second argument corresponds to the label, which means the solution or answer passed to the machine learning model or machine learning algorithm. And third argument corresponds to the hyperparameters to the machine learning model. So the difficult part of the machine learning is to optimize this kind of hyperparameters. And basically, it can be done in this argument, or the third argument, in the context of Hivemall. So for example, you can flexibly choose the loss function for this function, this option. So loss and log loss, if you pass log loss option to loss, the machine learning model will be logistic regression model. But if you prefer different loss function, you can choose the hinge loss or log loss, squared hinge loss, or modified Huber loss. There are multiple options. And also, this is the example of train classifier. But like I commented out, we also have a function called the train regressor, which actually predicts some value itself. So classifier gives the probability to you. But regressor gives you more like the actual predicted value, like number of cells or number of calls or stuff like that. Those kind of values can be predicted by using regressor. But in any cases, the usage is pretty much similar to that. And regression case, we also provide multiple loss functions. And also, you can configure more by using different options. Like, for example, you can configure arbitrarily the optimizers to train the model itself. So the simplest approach is called the stochastic gradient descent, SGD. But if you prefer more advanced one, we do support eta grad and eta delta and ADAM. And also, in order to make the machine learning model itself more robust for unforeseen future data, there's a technique called regularization. And we do provide multiple options to it as well. L1 regularizer, L2 regularizer, and elasticnet, RDA, stuff like that. And also, you can configure how to train the model itself iteratively, so which is also called learning rate. So you can configure those kind of advanced parameters inside of the option. But basically, usage itself stays simple. And if you are familiar with machine learning, or if you have some preliminary understanding of your data, you can do more on the third argument. So that gives flexibility, but stays simple. And once you finalize the training, what you can see is a table. So when you use Hivemall, machine learning model is always represented in the form of a table because it's originally coming from Hive, the data warehousing solution. And what train classifier gives you is called the linear model, which is mathematically represented like this right-hand side of the slide. And inside of the Hive, you can see the table looks like the left-hand side of the slide. So for every single feature, you can obtain the weight or importance of or coefficient of every single feature as a result of training. So this is the basic output from one of the most simplest machine learning techniques called linear model. So what it means is, okay, we now created a customer churn prediction model on the data called df.churn or stuff like that. And now it says, for example, okay, if the customer is in Texas, so it has 0.08 not possibility, but weight to churn, likely to churn from the service. So it's relatively higher than, for example, the other states. For example, yeah, it's pretty much higher than the others, all of the state. So that's training. And it's time to predict. So like I said, I'm going to use the test data frame for the prediction or evaluation. So we're going to create a view called the test from the df test data frame. And also, in order to make prediction, obviously we have to use the machine learning model we created before. So the model itself is also converted into a view named model. And the query looks like that. So what it basically does is to join every single feature between the test samples and the model itself. So, okay, so for this customer is living in Texas, and in the model, Texas has the weight 0.08, and you know what kind of value this customer has for the different attributes. And what it basically does is to calculate a weighted sum over every single attributes depending on the value they have. And it's a logistic regression model, so we finally need to take a sigmoid function so that the output converts into probability of the likelihood of churn. So in this query, for example, sigmoid function or extract feature or extract weight, these kind of functions are coming from Hivemall package, and it allows you to make prediction for the data stored in your database. And the final outcome, the data frame called the DF prediction, looks like that. So for every single test phone numbers, we have expected label. So we already know if this customer has already been churned from the service or not, because we already have a complete data set at the beginning. And very right-hand side of the slide, we have the probability, predicted probability for the customer, which represent if the customer is likely to represent the service or not. So this is the entire process to make prediction. And once you get the prediction result, you can apply evaluation and you can see how it's accurate. And the process is more like the same as before. You can create a view for the prediction table, and you can access to the prediction table from your SQL, Spark.SQL. And AUC or log loss are the specific evaluation metrics used for binary classification problem, and it's also coming from Hivemall package. And you can calculate the accuracy of prediction by using this kind of query. And it says AUC is 0.63 and log loss is 0.64. And to be honest, I'm not quite sure if it's good or bad, but commonly speaking, AUC 0.63 still has some potential to improve the accuracy because it's not that great. So that's pretty much everything to build your entire machine learning model, machine learning workflow by using PySpark and Hivemall. And for training, I have to emphasize that there are multiple options. So what Hivemall offers is not only the simple linear classifiers or linear regressors. Hivemall can do more. So we have these kind of options for classification and regression. And the notable ones are maybe like the factorization machines or random forest, which gives you much more complicated model, but you can expect a more accurate prediction result. So in case of factorization machines, the mathematical representation looks like that. And the model originally coming from the field of recommender systems, and now it's widely used in the context of the prediction programs. But in the Hivemall, you don't necessarily have to understand the mathematical details and how it works. The interface is quite same as the previous simplest one. But the only difference is the function name and options. So the function name now is called train FM, the shorthand of factorization machines, train FM. And the first and the second argument stays the same. It's feature vector and the label, so that's same. And third argument is more for the configuration. So this part requires a little bit understanding of the machine learning, this model itself. But if you have no understanding, you can stay here blank because there are some, default variables internally, so you can try it without any preliminary understanding of the model. And once you run the query, you can obtain the table as a machine learning model. But it's not that simple as the previous one. So in this case, the model looks like that. And the mapping between the original mathematical equation and resulting table looks like that. So if you strongly want to understand what it means, in that case, maybe you have to deep dive into the mathematical representation itself. But if you want to make just simple prediction from that, there's a function called the fm predict. So you can simply pass these kind of columns to the function. So you don't need to care about the, how this Bij is 0.18 and it looks like bad or something like that. You don't need to do this kind of discussion. Or in case of random forest, here, if you use random forest, the Hivemall requires you to pass the single special function called feature hashing, which actually compresses your original feature vector into much more space-efficient format. Because unfortunately, random forest is a very complicated machine learning model, and it consumes a lot of resources internally. So this kind of compression and abstraction is mandatory to make it possible. And you have to pass the original feature vector features into the function called feature hashing. And what it gives you looks like that. So if the feature vector looks like price 600 and the category is book, the output looks like that. So the feature name itself is actually hashed into some specific numbers. It gives you the compressed representation of your feature vector. And it has to be passed to the random forest function, which is called train random forest classifier in Hivemall. And the second argument stays simple, it's a label. And the third argument also corresponds to some options, hyperparameters. So in case of random forest, how many trees you want to have, and how to generate or how to initialize the parameters by using the specific seed value or something like that. So query stays simple, but model looks much more complicated. Actually, the model itself is encoded into that kind of representation. So you have no idea, I have no idea how to understand this model, unfortunately. But here, we do provide a function called tree export. So when you pass the model to the tree export function with some options, you can visually understand how this random forest model looks like. So basically, the random forest model is known as the tree-based prediction model. So the output looks like this decision tree. So you can see this kind of visualization, or if you're a web programmer, you can see the result in the form of JavaScript if-else statement, and you can directly embed the entire if-else statement into your web application if you want. And the prediction looks like that. I'm not going to go deep dive into it, but we also have the special function for prediction, so tree predict and tree ensemble. So you don't need to care about too much detail of the model itself. So that's pretty much everything about how Hivemall works with PySpark. So why this combination is actually preferable? I think the answer can be represented in the single statement. So we can keep scalability, but Python gives more flexibility, and your entire machine learning workflow becomes much more programmable. So like I said, Hivemall gives you the simplicity of the machine learning model. So you don't need to have, understand the mathematical details or stuff like that. But the interface itself stays SQL. So, where is the connection between our MySQL statement and my application itself? On that point, the Python connector is really important to bridge the gap between the Hive statement and actual application. So think about the entire machine learning workflow like I showed before. So for example, for preprocessing, of course, Hivemall offers multiple functions, but in some cases, you want to do more. In that case, of course, you can utilize the PySpark functionalities for preprocessing, for example. So the example I showed before for the preprocessing was super simple one. It's very basic. But in reality, you need to do more to make machine learning model more accurate and robust and scalable. So in that case, you have to do more actually before jumping into the training step. So then you can do much more complicated thing by using PySpark interfaces, for example. So let's say, for example, I want to normalize the column called account length. In that case, the PySpark provides a multiple functions to realize that, which is called, for example, min-max scalar, which actually normalizes the entire value within the single column. And PySpark also provides a cool function called pipeline. So you can create a single pipeline by concatenating multiple operations for the multiple different columns in the data frame. So those kind of flexible, code can be written for the PySpark data frame. And once you do that, you can obtain the normalized value for example, this account length column. And the once preprocessing can be done, it's time to make training, and maybe you can utilize train regressor or train classifier functions coming from Hivemall. So this kind of hybrid approach can be possible as a result of the PySpark interface. Training as well. So like I said, the optimizing the hyperparameter, which means the third argument to the train classifier function, is a very difficult part of machine learning. So you need to try multiple combination of the possible options to the single machine learning model to achieve the best of the best prediction accuracy. In that case, maybe you want to utilize for loop statement to try multiple combinations. In that case, you can do like that. So query can be defined before the loop, for loop. And the possible hyperparameters, the combinations can be defined here. And inside of the loop, you can issue the multiple different queries programmatically. There's no way to do like that purely on the SQL statement, right? So you need to issue the multiple queries by yourself, by hand. So it's not that easy, right? So programmability is very important. And prediction and evaluation as well. Make it programmable is really important. So in case of evaluation, for example, of course, Hivemall provides a multiple evaluation metrics, but there are more in the world. And there's no optimal choice to measure the accuracy of prediction. So in that case, maybe you want to try some, customized evaluation metric, which is coming from the PySpark MLlib package, or maybe a scikit-learn Python package or stuff like that. So those kind of functions can also be applied to the data obtained as a result of the prediction done by Hivemall functions, for example. And the last thing I have to strongly emphasize here is about visualization, because visualization is really important to understand your data, understand your machine learning model. But the query itself has no way to do that. So Python interface provides a way to do that. So for example, in case of the train classifier function, the classification model we obtained before, the model weight can be represented, visualized like that, and you can understand which attribute is actually important to predict customer churn. Or before preprocessing phase, you can visualize your entire data set, and you can get a more deeper understanding of your data and how the data looks like and what's the characteristic of that, and what the ratio of missing values or stuff like that. So everything is possible if you can utilize Python interfaces. But for the machine learning part, you can still utilize the Hivemall functions. So that's the combination you can do. So I want to say, from EDA, which is the shorthand of the exploratory data analysis, this is the step to understand your data, to production. Python actually gives the flexibility to the simple Hivemall functionalities, and scalability remains as is. So for example, this kind of entire machine learning workflow can be organized by Airflow, maybe. And for data analysis or visualization, you can utilize a Jupyter Notebook. And for training or preprocessing or evaluation, you may be able to use scikit-learn. Or once you get the entire machine learning model or prediction result, you can deploy that to your application. And maybe the application is written in Flask. So that's the future you can obtain as a result of using both Hivemall and PySpark. And that's pretty much everything about my talk. And here, GitHub link is here. And the second link is actually goes to the Jupyter Notebook that has every single code snippet I showed in the slide. So maybe I can show the oops. Yep. So this is how the link looks like, and the slide must be uploaded after the session, so you can access to the link. And basically every single code fragments are in it. And thanks to the Google Colabo environment, it's very easy to install the Spark environment and PySpark environment. So Hivemall installation has to be straightforward. There we go. Yep, and you can see how it looks like. And data frame is visualized more. Can be seen in the more visually stimulating way. And like I said, so the data is represented as the pandas, PyTD or PySpark data frame. So data frame can be converted into pandas data frame. And for example, you can understand the big picture of the entire data set by using pandas data frame describe function. Oh, the data is not still loaded. It's actually reconnected. But you can see the understanding of the data, or you can visualize the histogram of the specific column. Looks like that. And preprocessing can be done like that. So these are basically same as the ones I showed in the slide. All right, so where it is. So that's it, and thank you for listening. And if you have any questions,